Hello everybody, my name is Khaled Siddiqui, and in this video I'm going to teach you how to modify your battery in your GPS or any electronic device to last longer. This requires taking the device apart to have access to the battery, and this is how it's done. So first I'm going to explain how the batteries work, what you need to know about the batteries, and how can you increase the capacity of the battery. Alright, let's get started. So this is a Garmin Nuvi GPS. To be exact, it's a Garmin Nuvi 205W. And let's open this and see what capacity battery we have and what options we have to increase the capacity. So we will open this unit. Now I'm opening a lot of these units every day, so I make it seem very easy, but it might require a little bit of getting used to. May not be that simple in the beginning to just crack it open like it is for me, but alright, so we will remove this tape. Let's get a flat screwdriver to remove the tape. When you remove the tape, you always push it to the side. Don't pull it at a 90-degree angle, because if you do pull it up at a 90-degree angle, you will damage the cable. So you go sideways, and then you release the latch to get to the battery. This is where the battery is. So in order to change the battery's capacity, we have to add more batteries. Basically add one more battery. Question is, do we have room for another battery? In most electronic devices, you do have room for another battery. However, how you connect the battery makes a difference. You can't just put another battery and solder each color of the cable. Let's say you have a red, yellow, and black, and expect to just mix the two colors. You can't do that, because each battery has a circuit board right here, and that circuit board talks to the GPS or whatever electronic device it is. So you cannot have two parallel circuit boards. However, what you could have is two parallel cells. That's out before the circuit board comes in, which I'm going to show right now. Let me first see if we have room for another battery in this thing. Okay, so this is another exact type Garmin battery. This is a used unit. So I'm going to see first physically, is it possible? Is there enough room? So I put the second battery on top of the original battery, just as you see. And now I'm going to make sure the screen will close. I'm not going to connect this. I will not connect this. I just want to make sure this will snap close without any issue. Okay, it looks like it does snap close with no issue. Now right here, you see it's not closing. That's because of my cable. Let me fix that. That has nothing to do with the battery. It's the battery cable. It's this guy. So I'm going to here's what I'm going to do. I'm going to put this aside right here for now. This is all all I'm doing is finding out if it's possible size wise, because if it's not possible, then we have other ways. And bingo, all around it's snap close with no gap. The weight increased. Now it weighs a little more, but everything's close, snapped with no issue. So now I'm going to open it, and I'm going to tell you how to actually connect this battery to make it work. Okay? Okay, so we are taking it apart. All right, So we take the batteries out, both batteries. So assuming this battery is bad, so I'm just doing the surgery to show you, but assuming they're both good, we take them out. So now what I do is I open this to unplug this. I could force it and unplug it from here, but I don't want to take any chances. So I'm going to do it the right way, because you could break the plug if you do it the wrong way. Okay, so you see these two batteries. We want to make one battery out of these. Each battery right here is, let's see the capacity. Let me zoom in. So as you can see, this battery is 1.25 ampere hour, and so is this battery, 1.25 ampere hour. If we add these two, so 1.25 ampere hour means 1,250 milliampere hours. Okay, so that's in milliamperes. And that means that what this means is basically if this battery, if the unit draws 1.25 amperes, it will last for 1 hour. So, which is the same as 1,250 milliamperes. It will last for 1 hour. That is providing the battery is brand new. So, how do we mix these two batteries? Is not to cut each wire and go green to green, black to black, and red to red. If you do that, you create a mess. That's not how it's done. So here is how it's done. You have to do it very carefully, because when it comes to batteries, they have chemicals inside, and you cannot cut the battery itself. You cannot cut the cell itself, because you could cause fire or all other kinds of problems. What you need to do is you need to take out the controller board and use one controller board with two cells in parallel, not in series, because if you do it in series, what happens is you will increase the voltage. But if you do it in parallel, the voltage is constant. You simply increase the capacity or the current. Okay, so I'm going to take out this. This is my control board. This little circuit, it has a little microchip. Let me show you the little microchip. See that little chip right there? That little chip that you see right there is the controller. The controller of this battery, and that's the chip that talks with the GPS about the battery status, battery voltage, battery charge status, current status, and all that. Now right here, if you see, this is a cell. This is nothing but a cell. A cell past this circuit board, okay? Meaning on this side. On this side goes to the GPS or your cell phone or whatever the device is. But on this side, every battery is the same as long as they're 3.7 volts. Let me repeat that. Let me repeat. As long as the battery is 3.7 volt, okay? As long as the battery is 3.7 volt, every cell is the same. That means this highway battery, this part is the same except for the circuit board, which is different. This is another battery which is much bigger, but guess what? It's also 3.7 volt. This battery, which is even more bigger, also 3.7 volts. And this is a brand new battery from, let's say, Kyocera, and this one is also 3.7 volts. Let's see, where does it say the voltage? There, 3.7 volts. Okay, So all these batteries are 3.7 volt. What is the difference? The difference between batteries, all these batteries, is the size, the shape, and the circuit board or control board. Each circuit board that controls the charge intake and discharge is designed for the specific device that the battery is going into. For example, this circuit board right here is designed for a Garmin. If you take this and plug it into a cell phone, it will go crazy. It will not even know how much charge is left and whatnot. That's why you could use any of these cells. You could use this cell, you could use this cell, or you could use this cell that's big and huge and 2200 milliampere. As long as you take apart this circuit board and put the Garmin's original circuit board or whatever device you have the original circuit board. As long as you do that, any cell would work. Now there is a catch. Let me zoom into my face so I can explain this to you. There are two types, or I should say two technologies that they use to count the charge and discharge in a battery. Two different methods. One method is the voltage of the cell. So whatever this cell is, right here, the 3.7 volt cell, whatever the voltage is, if it is usually when it's a 3.7 volt battery, when you charge it fully, the charge reaches to 3.9 up to even 4 volts. It shows with a voltmeter. So it looks at that voltage and it guesses the capacity of the battery, whether it's 100%, 80%, 90%, or 70, 60, and what have you. That's one way of keeping the batteries, keeping a track of the battery's charge and discharge status and knowing what the percentage is or how much electricity is left in the battery, how much power is left. The other method is counting the current in versus the current out. This method that I'm teaching you works only if this circuit board is counting the voltage, is measuring the voltage and judging the capacity of the battery based on the voltage. If the charge circuit, if this little IC chip right here, if this IC chip is counting the current, then doing this will not get you anywhere, because as soon as the battery reaches its maximum supposedly capacitance, the circuit board will cut the flow of electricity to that battery pack, even though it has more capacity, but the chip doesn't know. The chip thinks, okay, this is a 1200 milliampere battery, and I have already counted 1200 milliampere has gone through, so the battery will explode or overheat, so I better cut down the electricity and it's not going to take the charge anymore. However, if it's the voltage type, then the chip will keep on sending electricity to the cell to keep on charging until the voltage reaches 3.8, 3.9, if it's a 3.7 volt cell. And then it will realize that, okay, now the battery has reached its capacity, and the battery cell itself also the current will reduce once it reaches its capacity. So basically there aren't enough chemical molecules inside the battery to receive the charge, and that's how it will fill up and no charge will be sent. The battery will not overheat, the battery will not explode, because it will cut out the power, the chip will, once the battery reaches its maximum capacity. These batteries that I'm doing this trick on, these are voltage-based capacitance measuring. It measures the capacity of the battery based on voltage. Now, based on voltage capacitance is neither one of the two methods, neither the voltage base nor that current base, is very accurate. And I'm sure you've seen it in your cell phones. Sometimes it says you have 50% battery left, and in a matter of 2 minutes it drops 30%, or it says 100% battery when it drops rapidly. As the battery gets old, as the battery ages, the report that it sends about its capacity is false. It's not real. So that's why you can't be totally relying on what you see on the screen as far as the battery capacity goes. Okay, so now let me show you how we do this. So right now, what we do is we just need the cell from this. We only can afford one circuit board can be there is only room for one circuit board at a time, basically, in each machine. So we have to cut this unit. Let me zoom in with this second camera here so you can see. So what we need to do is we need to cut this one. See, I'm cutting here because I don't want to cut here, because if I cut too close to this, it will be cutting the cell and the chemical spill will happen. So I don't want to cut that. Okay, so now what I'm going to do, let me go to the top. So do you see, actually let me actually remove the cell altogether so you can see much better. Okay, so this cell, which is silver, most of them are silver, is the same in all batteries, in all 3.7 volt batteries. It's only the circuitry, the board, the controller board that makes it device specific. So see, this is a Samsung cell. It's a Samsung cell. There could be a Samsung cell here. It could be a Samsung cell in a Canon battery. But this is a 7.2 volt, so we cannot take the cell from this because it's a 7.2 volt. We can only do this with a 3.7 volt. Alright, so this cell, if you notice, let me cut this. I'm not cutting the cell, I'm cutting these. There is plus and minus. You see this? Same thing here, plus and minus. So these plus and minuses can be shorted out. Or soldered in parallel. Okay, this plus and minus with this plus and minus, not these tips. Okay, not the tip. So let's see what we have here. It's very important to see which is plus, which is minus. If you reverse these, you will have fire. You will have fire, and that is not going to be fun. Okay, so now we need to see which is which. Now the reflection from this is causing the camera to go dark, so I'm gonna hold this way so it doesn't do that. So see this? Let me see which one is plus, which is minus, so that we don't have to do any mistakes here. Okay, so this is plus, this is minus. So I'm gonna write that down. Let me write that down. This one is plus, this is minus. This side is plus, this side is minus. And I'm going to do the same on this one. Double check, make sure. Same thing. This side is plus, this side is minus. So it's safe to add these together and get a higher capacity battery. One more thing you need to pay attention before soldering these two together. Make sure that you're 100% sure that both batteries are empty. If the one battery is full, the other one is empty, and you solder them, this battery will start charging this one, and both batteries will get really hot because there is no current limitation. It's like, you know, probably 10 amps will go through and you could have fire. So see, this circuit limits the current. This circuit board limits the current. But if when you soldering this to this, there is no current limitation. High current will go from here to here, filling this battery, trying to fill up this one, and that will cause a problem. But if both batteries are empty and you solder them together, then you will not have heat problem. They will not heat up or cause any issues, because in order for these to get to the state of equilibrium, equilibrium, in other words, to have level off their voltage. That's exactly what you need to do. Look at it as two swimming pools, for example. If there are two swimming pools, and if this is a swimming pool and this is a swimming pool, and they're both empty, and you are going to cut a pipe between, like a canal between the two, if they're both empty, there won't be any water rush through the canal because both swimming pools are empty. But if one is filled and the other one is empty, as soon as your canal is built, the water will rush from this one to fill it up, and that will cause major excessive water flow that could even destroy your canal. That's like a good way of putting it. That's the reason why before you do your surgery, make sure both cells are completely discharged. See, the control board, you can't parallel. So you have to remove this and only solder this to that. Okay. So now what I have is two battery cells with a single control board. And of course you have to tape it, and you can't short circuit it and what have you. You have to tape it and everything. And now if you put this inside the machine, you will have double the capacity. If you put this inside, you will have double the capacity. And luckily the thickness is enough for it to fit, so you don't have to worry about that. It's enough thickness. And yeah, so basically that's how you do it. Make sure both battery cells are empty, because you cannot have fully charged batteries and do that to a fully charged battery, because you could have fire and you could have all kinds of issues. But if the batteries are empty, completely empty, then you can do that. So yeah, so that's how you combine batteries to get higher capacity battery on your Garmin or any device. Oh yeah, and one more thing before I let you guys go. I could have done this with another battery too. So this is a higher capacity battery, right? This is a let me zoom into this one. This is a 3.7 volt 2200. So I could have done the same thing. I could go open this. Even though this has 4 wires, see, this has 4 wires, my Garmin has 3 wires. It doesn't matter because I'm using my Garmin control board. So I open this. And that's my cell right here, plus and minus, right here, plus and minus. So now this right here is battery temperature sensor. You see that right here? That's battery temperature sensor. Since it's like a thermostat type of thing. So you don't have to worry about that. In this particular case, you can just leave it disconnected like that. Because a temperature sensor isn't a part of a Garmin device, but if you have a circuitry in which temperature sensing is important, then you have to keep that. And you don't need this control. This is just your cell, plus and minus of the cell. If you don't know, if you can't tell which is plus, which is minus, you can simply see, this is exactly what I did. See, voila. What do you know? This company, whatever this company is, what's this company? It's a no-name brand. So they just did that. They parallel welded 2 batteries. At 3.7, they paralleled it, plus with plus, minus and with minus, with a single control board. That's exactly what they did. This is their control board, the longer one there. So this control board is actually controlling 2 cells. The same control board is controlling 2 cells. And this is the temperature sensor, as I said. just senses. It's a little, they call it thermocoupler is what this is called. Thermocoupler. Sees how hot the battery gets. And yeah, that's, so you could use a higher capacity. For example, this is a 1400 milliampere. You could remove the circuit board, use a Garmin circuit board with this, and have a 1400 milliampere battery pack. Okay, thank you for watching. Please make sure to like and subscribe.